Our last chapter, Chapter 10, is all about analyzing data. In this first section, we'll take a look at how to display data using different kinds of graphs and how to answer questions using the information that you see on those different types of graphs. The first type of graph we're going to look at is called a bar graph. A bar graph typically shows the breakdown of a bunch of different data into different categories. So for example, this bar graph is about casserole orders, and it has a bunch of different types of casseroles: tuna noodle, king ranch, baked ziti. And the bars coming off of each category show you how many there are. So for example, tuna noodle, if you look at the scale, each 2 bars is 10. So tuna noodle is about halfway, a little less than halfway between 40 and the next one 50. So maybe there are, say, 43 tuna noodle casseroles. The king ranch is just over 30, so we can estimate maybe there are 32 of those. The baked ziti is pretty close to 20. It's almost up to that second line, so maybe 19. Again, I'm estimating. Chicken with wild rice looks close to 30, but not as close as our last one was, so maybe we could say 28 there. And the lasagna goes all the way to the top, so if this is 40, the next line is 50, so that last line would be 60. So that's how you can kind of read what's going on in this bar. You want to see how high or how far over that bar is. And so if you wanted to know how many total orders were placed, you'd want to add up all 5 of these numbers. So if you get out your handy-dandy graphing calculator and add all of those numbers up and hit enter, you'll see that the answer is there were 182 casserole orders. Now if you wanted to know about what percent of the total orders were for baked ziti, we'd have to make a ratio. So we'd put the number of baked ziti orders on top, so that's 19, and we divide that by the total orders, which is 182. And we can do that on our calculator as well. So I'm going to bring our graphing calculator back in here, and we'll do 19 divided by 182, which gives you 0.104, or just we'll say 0.10. And 0.10, if you move the decimal place over 2, we know gives you 10%. So about 10% of these casserole orders were for baked ziti. Now, sometimes you're going to want to compare amounts of things in one category to amounts of things in another category. And for that, it can be useful to use what's called a double bar graph. So in this double bar graph, we're looking at the categories that we're looking at are safety, price, cargo, comfort, and mileage. And what these are customer satisfaction ratings with 2 different types of SUVs. And by putting both SUVs' ratings on the same bar graph, making it double, we can compare them. So for example, this double bar graph makes it easy to say which feature received the same satisfaction rating for each SUV. So you would look to see which category has the same red and blue bars. And if you look closely, you can see that for cargo, they both got the same rating. It looks like it was about 65. So we see the bars that are the same height right here, and we would say that cargo had the same rating. Then, if you want to know which SUV received a better rating for mileage, you could simply go to the mileage category and really easily see that the SUV Y's rating is much higher in mileage than the red bar for SUV X. So your answer could be SUV Y. The next type of graph we're going to look at is what's called a line graph. And what a line graph is really good for is showing change over time. So my example line graph is about humidity, and it shows the percent of humidity, which is either, which is in a percentage, and a lot of these are between 40 and 50, so they've kind of cut them off. And it also shows the percent humidity at different times. And so by showing the percentage and the times on this graph and connecting each dot with a line, you can kind of see that the humidity dot drops a little bit here, goes up, and then starts coming down. It also makes it really easy to zero in on the times when, for example, the humidity was the lowest. So you could go to your graph and you could look for the lowest point, and that's right here. And so you could easily say the answer to this question was at 4 a.m. when it's pretty cool out. If you're looking for which 4-hour time period did the humidity increase the most, you can see that down here on what you could think of as the x-axis, the increments are all in 4. And so if you wanted to look for the place where the humidity increased the most, you'd be looking for the sharpest increase in the line, or the biggest slope. And I think it's kind of a contest between from 8 to 12 and 12 to 4 to say which one is steepest, but I think it's this one right here. I think this slope is the steepest. You hopefully remember from our study of lines that when lines increased a lot, that made their slope steeper. So the 4-hour time period we're looking for here is from 12 p.m. because that's when this data point was right here, and it's going to 4 p.m., 4 hours later. Now, just like there are double line bar graphs, there are also double line graphs. And double line graphs are really nice because they can allow you to compare two different trends. In this graph, we were able to see the trend in the humidity. But if we looked at a double line graph, we could look at the trends in, for example, this one is about gasoline prices in different months. And we could compare the gasoline prices at two different stations. So it's not just what's happening at one, but what's happening at the other. So this double line graph, again, we have the months on the x and the cost on the y, and the graph is showing how cost changes over the time. So very frequently, line graphs are going to show you change over time. And so if you wanted to know in which month did station A charge more than station B, you would look to yourself and say, okay, station A is red, B is blue. So I need to look for where the station A dot is above the blue. And it doesn't take too long to see that that's happening right here. And if you want to figure out what month this is, it begins with M. So if we start with January, February, March, April, this one must be May. So the answer to our question here would be May. A second question that you might ask would be, during which months did the gasoline stations charge the same? And so for that, you'd be looking for places where the lines overlap because they're on exactly the same point. And so as I'm looking, it's pretty easy to see that there's an overlap right here. And so that's between March and May, so that must be April. And there's also an overlap right here. And so this is the second J. So if this is May, June, that must be July. So in July, there was no competition. They were exactly the same. Our last type of graph, now that we're done with line graphs, is called a circle graph. And circle graphs are really good for showing what percentage out of a whole a particular category makes up. So for example, this circle graph shows the types of degrees held by the faculty at a high school. So some of the faculty's highest degree is a bachelor's degree, others is a master's, and some is a PhD. And there are 31 bachelors, 24 masters, and 6 PhDs. And so and this is showing you what part of the whole, 100%, each degree accounts for. So it's really easy to see that there are the most bachelor's degrees, the fewest PhDs, and you can see if you combine the area of the PhDs and the masters that they are almost about the same as the bachelor's, which is a little bit more than half. Now, if you wanted to figure out what percent actually of the faculty held a master's degree, you know that we would have to hone in on this number 24. And so that would be the ratio of the master's degrees to the whole faculty. So definitely there are 24 master's degrees. And in the faculty as a whole, there are the 6 people with a PhD, the 24 people with a master's degree, and then the 31 people that just have their bachelor's degree. So if you add up those 6, 24, and 31, you're going to end up getting 61 people altogether. And then it would be time to bring our calculator back in and divide 24 by 61. So that's what I'm going to do right now. And when you divide 24 by 61, we end up with 0.39. So I'm going to write that. And when you convert that to a percent to answer the question, 0.39 would be 39%. So 39% of the faculty at this school holds a master's degree. And now you've seen how to interpret bar graphs, double bar graphs, line graphs, double line graphs, and circle graphs, and you're ready to do it on your own.